All right, guys, so at the end of sections 11.3 and 11.4, we want to kind of wrap things up about how you determine the relationship between an intercepted arc and an angle based on very specifically where the vertex of that angle is. Okay, so we try to make as many generalizations in math as we can, and if there's ways that we can categorize different angles together, and then we get to put a lot of notes that relate to each other on one nice sheet of paper to work with. That's what we're doing here. This sheet's called Dude, Where's My Vertex? And the sheet is kind of named after a scene in the movie Dude, Where's My Car, which is probably one of the worst movies in the history of the world. But basically they stand there for a minute and a half and all they say is, Dude, where's my car? So this is our little fun. Usually I would show that clip. It's just as stupid as it sounds probably, but it gets a little bit of a giggle. And then we get into, dude, where's my vertex? So when you're trying to work with the relationships between angles and their intercepted arcs, the first thing you want to ask yourself is, where's the vertex of the angle? And there are really four different choices. We could see an angle whose vertex is at the center of the circle, like angle 1 here. We could find an angle whose vertex is somewhere in the circle, not at the center though, like angle 1 here. We could have an angle whose vertex is on the circle, like one of these two angle 1s, vertex on, or we could have an angle whose vertex is outside the circle, like this angle, and this angle. As you can see, the vertices lie outside of the circle, okay? And we're basically going to get into four formulas, if you will, as to how those angles relate to their intercepted arc. Very simply, in a central angle, if the angle's vertex is at the center of the circle, the angle is equal to the intercepted arc. So we'll trace it out. There are the two radii in this case that form that. In this case, the measure of angle 1 would be equal to the measure of arc AB. Okay, central angles equal their intercepted arcs. We learned that actually in first semester, but we lump them back in. Obviously, you can see where these would relate to what we've been doing in this unit. Okay, a vertex in the circle. Okay, here's the vertex of angle 1. It is inside of the circle. All right, we have two different chords that form this angle. Okay, and then, as you remember from our notes, that would cause these two intercepted arcs. So the angle is equal to the average of the two intercepted arcs. Remember, we find the average of two things by adding them and dividing by 2. So in this case, the measure of angle 1 would be the measure of arc AB plus the measure of arc CD over 2. The average of the intercepted arcs. And the two intercepted arcs are formed by the two chords. So we have the arc facing the angle. And if we jump to the vertical angle, it's the arc facing the vertical angle. We could also have an angle whose vertex is on the circle, lies directly on the circle, like these two angles here. Okay, if that's the case, the angle is equal to half the measure of the intercepted arc. So in both of these cases, the measure of angle 1 would be 1/2 the measure of arc AB. Remember, regardless of whether they're formed by two chords, okay, which would be an inscribed angle, the definition of an inscribed angle, or whether it's formed by a tangent and a chord, technically angle 1, not an inscribed angle. However, you would find the measure of that angle exactly the same way. That's why we lump these together. Okay, and then lastly, we could have a vertex outside the circle, like these three here. When that's the case, we form far arcs and near arcs. Very simply, the arc furthest from the angle we call the far arc, the arc closest we call the near arc. All right. The measure of the angle would equal the far arc minus the near arc divided by 2. So in all three of these cases, well, there's different arcs here. Measure of angle 1 would be the measure of arc ACB. Remember, that's the far arc. Remember, we use 3 points to name a major arc, anything greater than 180 degrees. And remember, we would have to differentiate this arc, ACB, from this smaller arc, AB. Can't call them both AB. It wouldn't make sense. All over 2. Measure of angle 1 would be the measure of arc AB, the far arc, minus the measure of arc CD, the near arc, over 2. The measure of angle 1 would equal the measure of arc AB minus the measure of arc BC, all over 2. Far arc minus near arc divided by 2. So what we've done is we've taken 2 sections of work, 11.3, 11.4, plus central angles, which we learned a little while ago back in first semester, and we've created 4 simple formulas for you to remember and know how to work with these angles and their intercepted arcs. So, ask yourself, where's the vertex? If the vertex of the angle is at the center, the angle and their arc equal. If the vertex is randomly inside the circle somewhere, the angle is the average of the 2 arcs. If the vertex of the angle is on the circle, the angle is 1/2 the measure of the intercepted arc. If the vertex of the angle is outside the circle, far arc minus near arc divided by 2. And that wraps up Dude, Where's My Vertex? That's 2 sections of work in about 7 minutes.